Hello there, Rupert here from the Flying Buttresses. My friends and I would have been performing What the Tortoise Taught Us at this year's Beverley Puppet Festival. It's a fun, up-close, one-of-a-kind encounter with Zelva, the largest tortoise in the world. She's quite the sight to behold as she walks along, and you can interact with her by feeding her, petting her, and even asking her to sign a tautograph. She'll react to you, and she can do a few other things as well. But I don't want to give away all her secrets today, as I'm sure you'll get the chance to meet her yourselves at some point. Since unfortunately we can't bring Zelva to your town this year, I thought it would be nice to bring a smaller version straight to your homes instead. So I've designed this tiny mechanical version that can do some of the same things that her big sister can do. And today, I'm going to show you how you can make one too. Oi! That's my lunch! A note on safety. This project is suitable for older, supervised children and adults. I have tried to make this project as simple and as safe as possible, and I have tried to include several alternative construction methods that should suit a range of experience levels and abilities. But there are a couple of times where using a sharp knife, a saw or hot glue is really going to be the best way to get the job done. So younger children wanting to make a mini Zelva will absolutely have to get an adult to do those steps for them. You will need something flat with a bit of thickness to it to make your mechanical parts from. I made the prototype for this project from an old chopping board that was going to be thrown out. It's made from nylon and it measures 450mm by 285mm by 8.5mm. Something to make a shell from. I found a couple of these Christmas pudding pots in the back of a cupboard. Any similar round plastic bowl or hemisphere could be used. Cheap bowler hats of the type sold at joke and fancy dress shops. Toy shops carry child-sized medieval knights' helmets that could be readily adapted, and certain brands of Easter eggs come in round plastic blister packs. Alternatively, I'm sure that a suitably shaped plastic flower pot could be found, and perhaps even some brands of yoghurt are packaged in containers that would do the job. The pot doesn't need a round bottom for the machine to still function, so if all you have is a plastic cereal bowl, then that will work fine. Have a look around you for things that could be repurposed. If you really can't find anything, it's quite possible to make your own by covering the top of a round latex balloon with papier-mâché, which when dry will make a nice round hollow shape that can be easily painted and glued. Syringes. These remarkable devices have dozens of uses beyond medicine. So happily there are plenty of different suppliers out there stocking them if you don't already have a few tucked away like I did. We will need 2 2.5mm syringes and 4 20mm syringes. Sandpaper. We will be using this to tidy up the rough edges of any part that we cut. Anything made from plastic that we intend to paint will also need to be prepared in advance with sandpaper. For those that don't know, the numbers on the back refer to the size of the grit particles embedded in the paper. Slightly confusingly, the lower the number is, the larger the grit size is, and therefore the rougher the paper is. So the 40 grit on the right is the most coarse of the three. Cable ties. We will need 4. Shorter ones than these would have been better, but this is all I could get. If you're doing this activity with children, you may want to consider sticky tape instead. 5 flathead nails at least 50mm long and 3.5mm in diameter, with a nice broad head. A repair washer. This one has a 4mm hole in it, so it's a loose fit around the nail. If you don't have one, you could always drill a hole in a 2p piece. Finally, 2 split pins, sometimes called cotter pins. If you don't have one, any piece of wire with a loop bent into it will be fine for our needs. A roll of flexible PVC tubing with an internal diameter of 3mm and an external diameter of 5mm. Available from plumbing supply shops, aquarium stores or online. Pliers. These just happen to be attached to a multi-tool, but any old pliers will be fine as long as they can bend and cut through nails. A junior hacksaw. They're cheap, readily available and safe when used properly. A hammer. You can use this for driving nails through your chopping board if you don't have a drill. A ruler or rule. This one goes up to 150mm, which, for those viewers not familiar with the metric system, is 16/37 of a hectare. A pencil and pen. Simple but essential tools for marking out dimensions and shapes onto our materials. Sticky tape. Use this as an alternative to cable ties and glue. A glue gun. This will make holding parts together much easier. Don't ever leave them plugged in unsupervised. Pew! 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 A craft knife. Always be very careful with any kind of edged or cutting implement. Whenever we are cutting or drilling plastic or metal, we need to make sure that we are wearing safety glasses. Whoever made this pair can't even spell goggles properly. Okay, apparently Google are a search engine. I wasn't sure, so I had to Yahoo them. It's certainly possible to complete the project without the following tools, but it's nice to use them if you have them. A drill. This is a relatively modern cordless model, but a brace and bit would work fine too, and a pillar drill would be even better. We also need a 3mm bit to make a tight-fitting hole for our nail, and a 5mm bit to make a loose hole for our cable ties to pass through. A jigsaw, primarily used for cutting curves. I'll be using this one to cut corners when I run out of time. Making the shell. If your bowl has a lip like this at the bottom, you can remove it by making a series of downward cuts with a knife or saw. Be very careful if you decide to do this. It may not be clear due to the angle of this shot, but my left hand is well below the line of the blade as the saw is tipped right backwards. I'm also going slowly and using very little force to keep control over the tool as I work. Try and find a sturdy bench or table to build your projects on. Remember to protect precious surfaces with some thick card or a cutting mat. Now that I've gone around the lip making a series of small cuts, it's time to get the pliers and gently bend the plastic tabs back and forth until they fatigue and come away. That first one has come off with a resounding snap. I need to be careful just to fracture the plastic at the base of the tab and not crack the dome underneath. Luckily it's fine, but I need to proceed more cautiously and watch and listen to what the material is trying to tell me. You can see the characteristic pale stress line appearing as I waggle the plastic back and forth, revealing the point of failure. Sanding the plastic shell. There are two reasons for doing this. Firstly, I want to clean up all the ragged edges left from removing the ring at the bottom of the bowl, and secondly, to key or prepare the plastic surface so it can be painted. I can't actually get a hold of any paint at the moment, so I'll just be decorating the shell with marker pens at the end of the video. But I decided to show the process for the sake of completeness, in case anybody at home is planning on painting theirs. Of course, you can skip this step if you don't intend to paint your shell, or if you have made yours from papier-mâché. Without an electric sander, there really is no shortcut to doing this job if you want a good result. It's just a question of having patience. Preparing the syringes. Measure out 3 1-metre lengths of PVC tubing and carefully cut them using a knife or a pair of scissors. You might want to put down the cutting board or use some old newspaper to protect the surface of your table, just like I forgot to do. Open up your syringes and push one end of the tubing onto the nozzle. If you are having difficulties forcing the tubing on, you can always carefully dip the end in a cup of hot water to soften it a bit. We want an airtight fit, so if your tubing is a little loose, secure it with cable ties. Repeat this process until you have 3 lengths of tubing, each with a single syringe attached to one end. Fill a bowl or tub with water. I've used the bowl that I intend to make the shell from, but it can be any container as long as it can hold around a pint of water. With the plunger of the syringe pushed all the way down, submerge the end of the tube and slowly pull the plunger back up to the top, being careful to keep the tube under the surface of the water the whole time. Eventually we want our syringe and tubing to be entirely filled with water and without any air bubbles. However, all the air that was in the tubing will be immediately sucked up into the body of the syringe. Luckily, it's easy to get it out again. Hold everything vertically and flick the side of the syringe to get the air to float to the top. Then press the plunger slightly to purge all the air along with a little bit of water out of the end of the tube. Then put the tube back into the bowl and draw in some more water. Do this step a few times until most of or all of the air bubbles are gone. I don't want to get my table wet, so off camera I'm squirting the syringe out of an open door. Make sure that you are doing this part of the build in an area that you don't mind getting wet, and make sure to keep water well away from any electrical tools or devices. Now repeat this process for the other 2 syringes. Use your ruler to measure the thickness of your chopping board and make a note of the answer. We need to cut a square slot in one of the remaining syringes. The width of that slot has to be the same as the thickness of our chopping board, as this is what we will be using to cut our mechanical parts from. Grab an unused 20mm syringe and mark a centre line on the barrel flange. That's the name of the 2 tabs that your fingers press against as you hold it. It is a little difficult to do this accurately using just a ruler, so give it your best guess and estimate where the centre is. Now, divide the number you wrote down by 2. In my case, the board measured 8.5mm, so that would be 4.25mm. Now I don't know about you, but my ruler doesn't have any markings that show 1/4 millimetre on it, so I just drew 2 lines 4mm from either side of my centre mark. Using your hacksaw, very carefully make 2 vertical cuts on the 2 lines that you just drew. Then make 2 angled cuts to clear the rest of the material from the slot and clean it up using sandpaper. Alternatively, you could score a line between the 2 cuts with a sharp knife and use your pliers to break off the tab. I can't stress enough the importance of safety here. I'm being extremely careful not to press too hard and slip. If you have a vice or clamp, please use them. Children should be supervised if they are to carry out this part of the construction themselves. When you think you have finished making the slot, check it with a ruler, or even better, try sliding it over the edge of your cutting board. There is a little too much friction between the 2 surfaces for my liking, so I'm going to roll up some rough sandpaper into a tube and squash it between my fingers so it conforms to the shape of the slot. That way it will remove material from all 3 sides of the slot as I sand. You could accidentally take off too much plastic if you sand for too long, so if you need to do this to your one, check the fit regularly. Okay, let's try that again. That's much better. The parts slide easily but still make good contact with each other. On the side opposite the slot we just cut, mark a line that follows the curve of the syringe barrel and cut along it using the hacksaw. Once again, we're using the rough 40 grit sandpaper to neaten up the jagged edge left by the saw. It's probably easiest to do this by rubbing it back and forth on a level surface until the lip is worn down to the point that it is roughly level with the rest of the barrel. Now that you have removed your fingerprints, feel free to embark upon a life of crime, safe in the knowledge that none of your misdeeds can now be traced back to you. With the plunger pushed all the way in, connect your empty but modified syringe to one of the water-filled syringes via the tubing. Notice that if you press or pull the plunger of the full syringe, the empty syringe will move in the opposite direction by itself. The distance and rate of travel of the output syringe is directly proportional to how fast and how far we move the input syringe, and since our tubing is long and flexible, it is essentially a form of simple remote control, as we can operate our output syringe from a distance, even around corners or from another room. We need to make some changes to our small syringes as well. Mark one with a small wedge shape on the base of its plunger and a cut line on its barrel flange. Remove one half of the barrel flange just as we did with the large syringe, then cut out the wedge shape from the plunger. It makes sense to keep the moulded in rib intact so as not to weaken the plunger too much. Now get your split pin and push it through the wedge so that it lies along the rib with the eye or loop sticking out by about 5mm. You don't need to be very accurate at this stage in the build. I recommend that you hold it in place with a few small blobs of glue gun adhesive. Failing that, make some holes to push the pin through or secure it in place with sticky tape. It is best not to use too much glue at this stage, as we may need to take everything apart later to make adjustments. If you don't have split pins, get a small length of stiff wire and bend it into a loop using your pliers. Reassemble the 2 halves of your syringe and test to see that the glue and wire hasn't jammed up the action of the syringe. Unwrap a second 2.5mm syringe and repeat the process of marking out and cutting a wedge in the plunger. You don't need to bother with removing the barrel flange this time, but you will need to lightly glue in a second split pin, remembering to leave the eye overhanging the end of the plunger by around 5mm. Now attach the empty small syringes to the remaining large syringes. Once you have connected a large syringe to a small one, you need to be a bit careful if you intend to play with them. The large syringe can hold 8 times the amount of water that the small one can. If you were to quickly and fully compress the plunger of the large syringe, you would find that the two parts of the smaller one would separate quite rapidly, as 20 millilitres of water rushes to fill a container that can only hold 2.5ml. This would overpower the seal on the plunger and shoot it across the room, spraying water as it went. This is probably a safe enough experiment to try outside, as long as you point the small syringe away from you and everybody else. Label the ends of the connected pairs. The pair of large syringes will make the neck extend and retract. The 20mm to 2.5mm with the worn down flange will make the head tilt up and down, and the remaining pair will make the body rotate left and right. Next up, we need to manufacture all the parts that will make up the various links and joints in the mechanisms. Download and print the templates for this project. You can find them at beverlypuppetfestival.com or gianttortoiseshow.com. Alternatively, if you are looking for a challenge, you can try designing your own on a piece of graph paper. Carefully cut the templates out with a craft knife or scissors, making sure to read and make a note of the instructions that you will need to refer to later. Using a sharp pencil, trace around the templates onto the chopping board, leaving a small margin around each one to allow for the extra material removed by the saw blade. Make sure that you transfer over the centre locations of all the holes. I chose this chopping board because it is made from nylon, which is an ideal material for our purposes, as it cuts easily with the saw, is very strong and has self-lubricating properties, which will reduce the friction on the moving parts. So, even though the tortoise will be made from reclaimed materials, there's a very good chance that it will continue to function properly for a very long time. You may find it easier to make the holes, marked on the templates as a circle with a cross through it, before cutting out the parts. Use a nail to mark the centre of the cross and use your 3mm drill to make a hole right through the board. If you don't have a drill, use a hammer to drive the nail all the way through and then pull it back out again. Make sure that there is something protective underneath the chopping board, otherwise you risk drilling right through the board and into your table. Try and keep the drill completely vertical so that your bit doesn't drift in the material and come out of the other side of your part at an odd angle. Insert the 5mm bit into the drill and carefully refer to the template sheet to see which holes you need to enlarge. The plans have arrows pointing to all the hole centre locations with the diameter of the holes listed. If you make a mistake here, the parts will have to be scrapped, so always double check your instructions. Once you are happy with the layout of your parts, it's time to cut them out. As always, go slowly and concentrate on what you are doing. If you get tired, take a break and come back to it later. If you are allowed to use a jigsaw, then by all means use that. I made the prototype for this puppet with parts I cut with a hacksaw. It is entirely possible, just a bit more time consuming. If using the hacksaw approach, you may find that you need to cut a small section of board from the main stock and then cut your part from the smaller piece. That way you are more likely to be able to get the saw into all the intricacies of the shape. Clean up the parts with sandpaper. Not only will they look better, but they will slide better if they are smooth. Pay special attention to the 2 holes drilled in the base and the turntable. If there is any ragged plastic around the holes from the drilling process, remove it with your knife or sandpaper. It's time to work on the head and neck. You will need the little syringe with the filed down flange, 2 nails, the 2 head profiles and the L bracket, each with their holes drilled and their edges sanded. With the head of the tortoise facing your right hand, push the 2 nails through the holes and thread the eye of the split pin over the upper nail. Then thread the hole in the L bracket through the lower nail, making sure not to put it on upside down. You want to position the syringe so that the filed down section of the barrel flange is in contact with the top surface of the L bracket, so that the two parts are reasonably parallel. Slide the second headpiece onto the two nails, making sure that there is a small gap between all of the moving parts. Originally I intended to add a third nail to the head to act as a standoff, and add washers to the small lengths of tubing between all the sandwich parts to act as spacers, but that would have meant additional parts and increased complexity. As you will see, the puppet works fine as it is, and I haven't had any issues with the head falling off. By all means add your own reinforcement if your results differ to mine. Sand off a bit more of the syringe at this point if they don't fit well. I gave the mechanism a quick test at this point and it seems to be working okay. I'm going to need my hands back for other things though, so it's time to dig out the cable ties and use them to secure the bracket to the syringe. Use your ruler to mark a line roughly 10mm from the centre of the front hole in the L bracket and line up the syringe with it. Sticky tape would be perfectly fine to use here as well. If you are using cable ties, be careful that you don't tighten them too much. It is possible to jam the action of the syringe by squeezing the barrel too tightly. I only had these long cable ties, so I'm going to have to trim off their tails. You could use a sturdy pair of scissors to snip them off, but it's much better to carefully use a knife to cut them flush. Any electrician will tell you that the pointy end of a badly trimmed cable tie can give you a surprisingly nasty scratch if you brush up against one. I'm going to be handling this puppet a lot whilst I assemble it, so I want it to be safe and comfortable to hold. Let's work on the mechanism that will rotate our tortoise from side to side. Push a nail up through the hole in the centre of the turntable base plate and drop a penny washer onto it and stack your turntable on top. Make sure that your turntable and base parts are the right way around. They both have a second hole drilled in them, which should be on their left hand side as in the video. Holding the base down with one hand, rotate the turntable with the other and check that it moves freely. Get your marker pen and place a dot on the nail just above the top of the turntable surface. In this instance, we don't want to cut the nail flush. I have been looking at the chopping board and I can see that it is slightly warped. This might cause a slight upwards and downwards movement as it rotates around the nail. By leaving the nail slightly long, we can compensate for that vertical wobble and ensure that the turntable can't jump off the pivot. Remember to clean off any burrs with your coarse sandpaper. Whilst we are making the nails safer, let's get the head back and trim those off as well. Again, I'm leaving them a little long as I want to make them safe to handle for now. I can always go back and trim them later if I need to. Like many pliers, mine have a wire cutter on them, which will go through these soft nails. Put your goggles on for this job and point the work well away from you as you cut the heads off. You could also use your hacksaw for this job. Next up, we have what may be the most challenging part of the build, accurately drilling a hole through the body rotate hinge. With the part upside down and the cable tie holes pointing to the left as shown, mark a point 9mm in from the right side along the centre line of the part. Use a nail to make a small hole or centre punch at the point you intend to drill. This will help you keep the drill on target. Keep checking that you're holding the drill straight and not leaning over at an angle. It doesn't need to be perfect, but our tortoise will work a lot better if you do a good job here. I'm drilling out a little at a time so I can keep track of how straight the hole is. As I'm going to break through the bottom of the part, I'm grabbing some scrap material so that I don't drill into the tabletop. It looks like my patience has paid off. The drill hasn't broken through the side of the part and it hasn't wandered too far off its intended course. It's a good sliding fit on this nail, so I'm going to call that good and move on to the next step. I recommend that you do the next few steps in one sitting for the sake of safety. You don't want to stop halfway through and leave upright nails lying on a table for somebody to accidentally lean on. Take the turntable off the base and push a new nail through the pivot hole from underneath. The tiny clearance gap between the parts created by the washer not only reduces friction, but stops the head of the nail dragging along the top surface of the base. Pop the turntable back on and locate the second hole in the base. Push a nail up from the bottom through the hole. Check that everything still moves freely. Place the body rotate hinge onto the nail and turn it from side to side. If it binds up on the base, the chances are that the hole you drilled isn't straight enough and you will need to try again. If everything feels good, mark a cut line on your nail with a marker pen and use pliers or a hacksaw to cut the nail flush with the top of the hinge. Use coarse sandpaper to smooth off any burrs. Find the syringes that you put aside for the body rotate function and check the label that you wrote on them. If your little syringe has a modified flange, then you've used the wrong pair for the head mechanism and you will need to swap them over. Hook the eye of your split pin over the nail that is protruding from the turntable. At this stage we want to make sure that the plunger of the small syringe is fully depressed and that all the water is in the tubing and the big syringe. Push 2 cable ties through the holes in the hinge as shown. It is important that the heads of the cable ties are on the left-hand side of the syringe when viewed from above. It will be easy to explain why later, but for now, just copy what you see here. Make sure to trim the tails off your cable ties to prevent them binding up in any of the moving parts. Tape or glue would work fine as alternatives for this job as well. Just use it sparingly as we may need to take things apart again. Here I have accidentally left a gap between the barrel flange and the front edge of the body rotate hinge. Those two parts should be butted up against each other, which gives a greater range of motion than what we see here. Off camera I have pushed the syringe back against the body rotate hinge and you can see the difference it has made to the amount of rotation we get. Use your marker pen to put a dot on the nail, slightly above the eye of the split pin. Once again we need to compensate for the slight up and down motion as the body rotates, caused by the warped chopping board. To further help keep things in place, use your pliers to bend the nail forwards. This creates a slope that the eye wants to slide up and down, and the hook shape keeps the split pin from jumping off the nail. Cut off the sharp ends and deburr with sandpaper. We now need to attach the two parts called the big saddle and the little saddle on the template sheet. As I have marked the position of these parts on the turntable template, you can skip the layout step that I am demonstrating here. I didn't design the templates until after I had finished the tortoise puppet, so here I'm making it up rather than following a set of plans. I'm using a ruler to keep the lines I'm plotting straight. I want the big syringe that the saddles will eventually support to be mounted as centrally as possible on the turntable, but I also want to avoid the saddles crashing into any of the other moving parts. Once I have a rough idea where I want the two saddles, I'm pressing a syringe down on them to adjust the positioning. I'm then marking around where they will sit and gluing them in place. I mentioned earlier that we need to make sure that the cable tie heads are on the left-hand side of the syringe. As you can see now, if they were on the other side, there is a risk that they would interfere with the positioning of the saddles. You can see how the placement of every single part of a mechanism is crucial to the success of the project. You might be wondering why the turntable is such an odd shape. Well, I said earlier you could cause the small syringe to fail quite spectacularly if you tried to force the volume of water of the larger syringe into it. The turntable swivels to the right until the edge of the cutout jams into the moving hinge with its steel nail reinforcement, forming a hard mechanical stop and thus preventing you from moving the full volume of water and popping the small syringe like a cork. At this point we are pretty much done with the body rotate mechanism, so set it aside for now and finish off the neck retract mech. This is the simplest part of the build and requires nothing more than a dab of glue to finish it off. Gather up the L bracket and head assembly and the pair of large syringes. Feed the L bracket into the slot that we cut and check for a good sliding fit. Sand away more of the slot if things are too tight. If this fit is good, put a dollop of glue on the end of the plunger and press the L bracket onto it until the glue hardens. As there really isn't anything to adjust here, we can be confident that we won't need to take this apart again later to make changes, so we can use more glue to build up a fillet to add strength to the joint. We do need to be careful that we don't get any glue near the jaw pivot, as that could stop the mouth opening and closing. Now give it a test. The syringe extends and carries the L bracket and head along with it. The purpose of the slot is twofold. Firstly, by removing the flange, the bracket and barrel can sit closer together, making for a more compact neck shape. And secondly, it guides the motion of the big plunger, which might have a tendency to droop to one side as it extends, due to carrying the additional weight of the head mechanism. Now it's time to join all three stages together. If you have removed it, reinstall the body rotate hinge back onto the turntable by threading it through the two nails as before. Mount the big syringe into the saddles and make sure that all three tubes are facing the back of the tortoise. Try and keep the head level and not tilted to one side. Position the flange 15 mm from the front of the little saddle as shown, and use small beads of glue to join them in place. You have a few seconds before the glue cools, so put everything on a level surface and rotate the big syringe to adjust the angle of the head. This completes the mechanical assembly portion of the build. We still may need to make a few tweaks when we come to fit the shell, but for now let's just go through the range of motions and see that everything is working. Here I'm drawing a stencil that will be used to mark out a doorway in the tortoise shell. You don't need to do any drawing, just download the template pack and carefully cut out the two shapes called tube exit and head entrance. If you were using a craft knife, remember to put down some scrap material to protect your tabletop. With the templates cut out, attach one to your bowl using tape. You could also use sticky tack if you have some. I'm leaving a gap between the lip and the template as I originally intended to give myself a bit more height. The printed templates have this extra clearance included, but feel free to adjust them to fit the shell that you have chosen. Draw around the template with a pencil, moving the paper and tape as necessary. You can achieve a pretty good result if you are careful. Here I'm transferring the centre line from the template onto the shell. I'm then using the edge of a piece of sticky tape to continue that line up and over the curved surface and down to the other side, where I will make a mark with a pencil. A flexible dressmaker's tape measure or a piece of string would work as well, although the advantage of using tape is that it stays in place by itself. Once we have a centre line, we can use our tube exit template to transfer a cut line to the rear of the shell, knowing that we have located it where we want it. Of course, if you have a steady arm, you could always skip this step and freehand a shape onto the curved surface. With the cut lines marked out, it's time to remove the doorways with a hacksaw. As soon as we cut through the brim around the bottom, the bowl will become a lot more flexible and possibly more prone to cracking if we distort its shape too much. Try to support the plastic as much as possible with your free hand whilst keeping your fingers away from the blade. The trick here is to use very little force and to constantly adjust your grip as you follow the line around with the saw blade. Stop and reset if the blade gets stuck, rather than trying to free it by pushing harder. Patience is key, as we have already invested a lot of time shaping and sanding this bowl, and we don't want to break it and have to start all over again. If you have used the papier-mâché method to make a shell, you can just use scissors to cut out your openings. Try to follow the line as closely as possible, We can neaten things up with sandpaper later to some extent, but it will benefit us to do a good job here. At some point you will find that you can't get the hacksaw any further into the bowl. Get your craft knife and carefully score along the last section of the curved line. Please be careful doing this step. Children should definitely have an adult do this part for them. The idea is not to try and force the knife all the way through, so don't press down hard as you will likely slip and hurt yourself. You just want to break the surface so that when you start bending the plastic back and forth in your hands, it starts to fatigue and peel away. You can always go back in again with a craft knife and score a bit deeper later on. Keep bending and scoring until the part either snaps off or until the plastic is so thin that you can slide your knife through it with minimal effort. Turn the bowl around and repeat the process of making a doorway on the other side. Now that a large section has been removed at the front, the bowl is even weaker, so taking a gentle approach to sawing is more important now than ever. This is why we did the slower task of removing the larger door first, so that the amount of time we spend working on the bowl in this weakened state has been reduced. By stopping often to change the angle of approach, it should be possible to remove this second, smaller doorway just with the hacksaw. If you do need to use your craft knife, take extra care as the bowl is a bit harder to hold onto now that we have cut holes in it. After the doorway is removed, use a roll of sandpaper to neaten up the rough edges and smooth the cut line into a sweeping curve. Roll up some sandpaper into a tube and start smoothing out the jagged edge left by the hacksaw. You can remove material surprisingly quickly this way, so don't stay in one spot for too long and stop often to check your progress. We want to aim for nice sweeping curves, so try and remove all the little tool marks if you can. By gently squeezing, you can change the shape of the bowl, which sometimes helps to get the sandpaper to where you want it. Wipe off any dust from the sanding process with a damp paper towel, remembering to clean the inside as well. With the larger opening towards the front, test the fit of the shell on the base. Position the head centrally under the highest point of the curved opening. Test all the mechanisms and see that none of the parts collide. Here we can see that the syringe that moves the head is catching on the top of the head entrance. I could probably ignore this and just glue everything down, but I'm going to try and sand the syringe down and see if that helps. Alternatively, I could remove some more material from the shell, but that is a lot more work and I'm pleased with the shape that is currently. I could also try and remove the glue holding the big syringe to the saddles and adjust that 15mm gap we left to something like 17mm. There are a few options to try, but sanding down the syringe seems like the easiest. We're almost finished, but before we glue everything down, we need to decorate the shell. Painting is definitely not my field, and it's not really meant to be the focus of this video. I couldn't get hold of any paint locally during lockdown, but if you have some at home, by all means decorate the whole puppet as much as you like. It's up to you how far you want to take this, but you could even build up some lumpy scales on the back of your tortoise by adding on bits of paper, air drying clay, or even epoxy modelling putty. I did want to add a bit of decoration to the puppet before we move on, and I was able to get hold of a silver marker pen, so I'm doodling a hexagonal pattern that looks a little bit like scales. I found an old sheet of stickers that had some eyes on it. You could also use some stick-on googly eyes, cut something out from a comical magazine, or just draw directly onto the nylon with a permanent marker pen. It's time for the final fit of the shell. Get the body rotate mech into its middle position, centre the head under the shell and use small dabs of glue to join everything together. Make sure the glue attaches the shell to the base, allowing the turntable to move freely inside it. This way your shell stays still and the head and neck swing back and forth inside it. Alternatively, you can glue the inside of the shell to the turntable, as I did with my prototype tortoise. This means that the shell, body and neck all move side to side together, whilst the base remains still. It's up to you which one you like better, and if you use the glue sparingly you can easily change between the two. So here we have the completed Zelva tortoise puppet, made from repurposed materials featuring 3 remotely operated, hydraulically actuated mechanisms all crammed into a space the size of a honeydew melon. Of course, looking at her from this angle, it looks positively roomy inside that shell. I'm sure those of you who have got this far could think up another mechanism or two that we could fit in there. Perhaps you could add a moving lower jaw, or eyes that could blink, or even a little pink tongue that could waggle around. You could also look into improving the control system. Maybe you could design some sort of box that holds all the input syringes together and uses levers to pull and push the plungers rather than having to use your fingers directly. Once you have made one Zelda puppet, why not make another for a friend and put on your own puppet shows? Or use them to build a Hungry Hippo-inspired tabletop game I like to call Brassica Massacre, where the object of the game is to try to scoff your way through the cabbage patch before your opponent and become the champion of the allotment.